Either take out a blank piece of paper, or if you want it, if you have your book and you want to turn to page 323, there's a blank page there. We have a little bit of notes, which will not take us all of class, which means we will end early and you will have time to work on your take-home quiz, which is due tomorrow. And we are going to mark that in class. So that might be nice for some of you to use that class time to do that. Absolute value functions. So in addition to all the other graphing that we've had, yesterday, well, in chapter 2, we learned how to square root any graph. Yesterday, we learned how to do 1 over any graph. And today, we're going to learn how to absolute value any graph. Now, you know what absolute values do already, right? What do absolute values do to a negative number? Make it positive. What do absolute values do to a positive number? Keep it the same, right? So basically, all that's going to happen is all of the negative y values become positive y values. And if you took negative y values and made them positive values, that's like flipping them over the x-axis. So we've done that before. And so what's going to happen is we're going to get questions like this. You're given that f of x equals 2x plus 3. And I'm going to graph f of x in blue here. That would be a y-intercept of 3, a slope of 2, up 2 over 1, down 2 over 1. Right. There's the blue line. A very important point and something that you should always label on your graphs, because sometimes, like if you drew this line and didn't label the x-intercept, sometimes on the exam they have deductions saying, if you don't label your x and y intercepts, we're going to take off a half mark. So the rule of thumb is if you can label your x and y intercepts on any graph, do it. If you can't, because it's like a sine graph that's moved up a little bit and it's like weird numbers, then you won't be required to do it. But if they're easy numbers, for sure. And so how do I find this x-intercept? It's going to be something comma 0. I could algebraically plug in 0 for y and solve. That means move the 3 over, divide by 2. So I'd get negative 3 over 2 comma 0. That's going to be important because I'm going to, on the same, oh, that's not green. I was going to go green. On the same graph, I'm going to graph this. And all that will do will change negative y values to positive and anytime you change a negative y value to positive, you're going to flip it over the x-axis. So here's my original graph. Do we have any negative y values? Yes. I'm gonna just, this is the only part where the y values are negative, right? I could label a point on here if you wanted. I could plug in if I plugged in negative 3, do you see that you would get negative 3 times 2 negative 6? You get negative 3, negative 3. That's a point on the original graph in the negative section. If the absolute value changes negative y values to positive, what's going to happen to negative 3 comma negative 3? It's going to be a new point. Negative 3, the x value doesn't change, but the y value changes to positive. That's one single point. If I want to do the whole graph quickly, I just take this red part that's negative, flip it over the x-axis. That's going to go up there. This part that was positive is going to stay positive because an absolute value doesn't change positive values. And that is graphing absolute values of functions. All you're going to have to do is take the parts that are below the x-axis, flip them over the x-axis to get your new graph. So what's the skill that you have to have? You have to be able to graph the original function. Okay? Could we have done this using our old techniques? Yes. Okay? The green graph here, I'll write it in green. Absolute value of 2x plus 3. You could have done this with transformations. Do you see that the parent graph is the square root of x, which is the v? What's the 2 going to do inside the function? Yes. Horizontal compression by a half. And we have a horizontal translation. So if you were going to use our very first unit to graph this, it would have to be in factored form. The 2 makes it narrower, and then you would shift it 1.5 to the left. You see that the shift of 1.5 to the left shows up? I actually think this is a lot harder to do using the first technique that we learned. In this example, it's way easier to draw the graph on the inside and just flip half of it up. But you could have done it as horizontal compression by a half, then moved 1.5 to the left. So it's nice to see both methods, right? We saw that sometimes with the square root graph, you could use 2 methods. Sometimes one method is easier, sometimes the other method is easier. Okay? But the first method only, transformations only worked if it was the absolute value of x. But if we put anything else inside of those absolute values, we have to use this new method. So for the second example, it's from chapter 1. You have a polynomial already in factored form. How do you graph polynomials if it's in factored form? Well, the factors would tell us the following x-intercepts. -3, 0, 0, 0, and 2, 0. Then if you multiplied this out, can you see that you would have a positive x cubed graph? So you know what its end behavior is. You would know that it starts down here and ends up here. Each of your x-intercepts has a multiplicity of 1. So that means your graph goes straight through, straight through, straight through. And so in blue, we have the original graph. I'm going to change colors. And do the absolute value of this graph in green. Okay? All that's going to happen is wherever your original graph y values are negative, I'm going to highlight those in red. You see that it's negative here, below the x-axis, negative there. That's where your y values would have been negative. The absolute value makes your y values positive, which flips that over the x-axis. So this red part gets flipped up. This red part gets flipped up. The other sections would stay exactly the same. And so the absolute value of that cubic graph looks like something bouncing on the ground. Are you okay that we're ending with a topic that's not super hard? Is that okay? Or are you finding this,
No,
this is okay?
no,
It's too hard. Okay. Where, yes.
On a test, do we have to show any work at all?
Well, if they gave you the graph, flipping it over is super easy. Okay. I didn't have to give you this graph.
So you might have
You might have this and ask to graph this, so you would have to know how to graph the original on your own and then flip it.
but you don't have to show anything with flipping it, just flip it.
Flip it is just flipping it. If they have points labeled, you would label nice points, right? Like had they labeled this one as 1, -4, which I don't. Yeah, it is. Perfect. Okay. If they had labeled that as 1, -4, then you should label this as 1, +4 to show that that y value went from negative to positive. But other than that, pretty straightforward. Now, where these things could get complicated is if they start combining stuff from this idea and our first unit. So I'm going to give you a couple of examples. Okay. First of all, I'm going to give you the graph of f of x. This is our last example. All right, I'm going to make up f of x, y equals f of x is going to be our blue graph. It goes from here to here, down to here. And this is 1, 2, 3, 1, 2. There's our blue graph. Yeah, I'm happy with this. Okay. Whew. So what am I doing? I'm combining transformations and the absolute value function together. How do we think about this? This 2 is outside of the absolute value. That is going to be a vertical stretch. I'm going to vertical stretch whatever this is. But I don't know what it is yet. What does the absolute value do? It takes whatever's negative and flips it up. So whatever's inside, if there's negative things, it's going to flip it up. So then I look inside, and on the inside of these absolute values, I have f of x minus 1, which means my f of x graph has to be moved left, right, up, or down. Down. Because the minus 1 is not in with the x. The minus 1 is outside of, it's inside the absolute values, but if you just look at, and I'll do this step by step, I'm going to color code things as I go. The first thing I'm going to graph is just f of x minus 1. What would that look like? That would just take this graph and move it down 1. Does that make sense? So in purple, I would now have this point to this point. It's going to go down to this point. That would be f of x minus 1. Then in orange, I can now do this, right? I could graph that. What would that do? That would keep this the same, this the same, this would get flipped up, and that would stay the same. So the orange, the absolute value, just takes that negative part and flips it up. And then finally, what color haven't I used? Green. Finally, I can do this in green. What does the 2 do to this graph? It would take the orange graph and do a vertical stretch by 2. So these 2 points are going to go up to here. 0 is going to stay the same. This one's going to go up to there. This one's going to stay the same. So you could get transformations and absolute value, or transformations and square root graphs, or transformations and 1 over f graphs combined. And the logic between thinking what's happening is going through and saying, okay, what does this 2 do? It does a vertical stretch. It vertical stretches what? It vertical stretches the absolute value, which is the orange graph. But in order to graph the orange graph, well, I have to absolute value f of x minus 1. What's f of x minus 1? That's my purple graph. So my f of x graph got moved down 1. The absolute values kind of act like brackets. You have to do the inside first. Once it's been moved down 1, the absolute value would take that bottom part and flip it up. That's the orange graph. And then I could do my vertical stretch by a factor of 2 and get my green graph in the end. So sometimes things get combined and you sort of have to ask yourself, what does something do? And what is it doing it to? The 2 is a vertical stretch. What is it doing it to? It's doing it to this absolute value thing. Okay, so before I can vertical stretch it, I need to know what that absolute value looks like. So I go to my absolute value, I'm like, oh, inside of that is f of x minus 1. I have to do that first. So we start with the purple, we move our blue graph down 1, then we can reflect it over and finally stretch it by 2 to get our final graph. I think on your chapter 2 take-home quiz, I gave you a combination 1 with a square root graph. That was from an exam last year or the year before. Okay, that's where we'll stop.